Hey, what's going on, guys? Mr. Catlin here with your homework help for the week, looking at lesson number 12 and getting right down to it. So, you have this list of equations and this list of graphs along with it. And your job here was to match them to their appropriate graphs. So, 6 equations, 6 graphs, 6 constants of proportionality. We learned last week and we've been practicing it this week. We can find the constant of proportionality where x equals 1. So I'm going to zoom in on this one so I can see this a little bit better. And I think I made a dot for every one of these graphs where x equals 1. X equals 1, x equals 1, x equals 1. So what I'm going to do is I'm going to go around and I'm going to write the constant of proportionality that I see it landing on. Like for this one's really easy. Number 5 here, x equals 1 when y equals 2. So that ordered pair is found. So that means that my constant is 2. Over here, when x is 1, I find my dot here. So when x is 1, it looks like y is 1.5. So that would be the same as half. 1, 2, 3 halves. 3 halves. And then over here, when x is 1, it looks like this has been split up into 1, 2, 3, 4 sections. So it looks like this would be 1/4. So this would be 1, and the constant of proportionality would be a quarter. So I'm going to put a quarter for this one. This one was 3/2, or 3 halves. Let's look at the other 3. Okay, number 1, x is 1, and it looks like this is 1 right here. So 1, 2, 3, 4, 5. They split this up into fifths. So this right here where the dot is would be 4/5. So 1 and 4/5. It's going to be on there. So I'm going to put my constant for that one is 4/5. When x equals 1 here, it lands on this spot, and they broke this one up into 1, 2, 3. So these are thirds. 1/3, 2/3. So this is 2/3, 1 and 2/3. So its constant is 2/3. And then lastly, this one is 1 and a little bit more than 1. They've broken this one up into 1, 2 thirds again. But this is the fourth third. 1, 2, 3, 4, or 1 and 1/3, which is 4/3. So this one would be 1 and 4/3 when x equals 1. So its constant is 4/3. So that should make the matching really easy. A is going to be matching the one that is 2, which would be this one right here. This is A. And then B is 4/5, which we saw this one to be 4/5. The constant, the proportionality on C is a quarter. So that would be this one, C. And then D is 2/3. So that would be this one right here. And 4/3 is E. 4/3 is over here. This is E, which means that F, by process of elimination, must be this one over here, which was 3 halves. There you go. There's your matches for that one. Let's move on to the next question, number 2. The graph below shows some data from a coffee shop menu. One of the graphs shows cost in dollars versus drink volume in ounces, and one of the graphs shows calories versus drink volume in ounces. All right, so what we have to do is figure out which one is which graph is calories, which one is drink ounces. Okay, so the first thing that I did when I was thinking about this problem was I was thinking, all right, which one of those two things would be proportional? Because it looks like, and I think there was a typo on this one. This was supposed to be 24 and 360, but I think they put it at 350. So that dot should be a little bit higher. And that's important because if it wasn't a little bit higher, then we wouldn't notice that it's a straight line that goes through the origin. All right, so that one is straight that goes through the origin, which means it's like a proportional relationship. This one over here looks like it goes through all the dots and makes a straight line, but it doesn't go through. You're paying like $3 for something, and then the ounces are not as expensive because you have a less flat. It's more of a flat line than the other one's more steep. Okay, so One is in ounces of volume, and they're both in ounces of volume, but one of them is showing calories, and one of them is showing dollars. Well, I don't think you're going to be paying hundreds of dollars for ounces of coffee. Maybe in the future, and I never thought we'd be paying $5 or $6 for a cup of coffee, but we are. But we're definitely not paying hundreds or fifties of dollars for cups of coffee. So this leads me to believe that the one on the left is probably dealing with money. So my guess is this one over here is dollars versus volume. Because yes, I could see paying $1, 2, 3, 4, $5 for coffee. But I'm not seeing paying this much, so this one must be calories. So just a little common sense there to answer part A. Which one is which? Give them the correct title. So we've done that. And then part B says, which quantities appear to be in a proportional relationship? So it appears that the calories are. So I'm going to write my answer for that down here at the bottom for part B. Part B. Okay. I would say calories appear proportional. And I explain how we know. Its graph is straight and through the origin, right? You should know that. I'm not going to write that. That should be something you know. We know it's proportional because what its graph's doing. So I'll let you write that out on your own. If I see you put dot, 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 I'm not giving you credit on that, by the way, if you turn that in. You're just copying down what I write. For the proportional relationship, find the constant of proportionality. What does that number mean? Okay, so we don't have to do it for the one on the left. We just got to do it on the one on the right. So we got to find our constant of proportionality. Now, we could look at one, and it's like right here. So I'm guessing my answer is going to be 20, 25, somewhere in that range. Maybe a little less than that because it looks like it's less than the halfway mark. Maybe 15, 20, somewhere in that range. But I can find the exact number by taking two of the ordered pairs and just dividing them. So the y divided by the x, which in this case would be 150 divided by 10. So for part C, we're going to write 150 divided by 10 is 15. So this means 15 is our constant. 15 calories, right? Because that's what we're counting here. Calories per, what's the other quantity? Ounce of coffee. So for every ounce you're drinking, it is 15 calories. And there we go. There's your shown work and help for the first page of your homework this week. See ya.